Okay, so we're going to get started with exercise 205, and I think what's important to understand as we go forward is I will be giving you less and less scripting as we go on, but for now we still have certain objects and certain techniques that I want to teach you. Therefore, what we're making is pretty much everybody's going to be exactly the same, and that's the nature of things. And there's really two different ways of looking at modeling in something in Rhino, and that is that we can model basic shapes and then continue to add progressive levels of detail, which is kind of a top-down approach, or we can start to build up from the small scale. And what we're going to be doing today is we're going to build a small piece of a bridge, and then we'll use that bridge as a block reference and put a bunch of them together long term. For today's exercise, we're just building one piece of this bridge, and I've designed it such that it'll test a lot of the stuff we've already kind of gone through in class, and at the same time you'll learn a few new things, and you'll have to work a little bit more in 3D and start to understand what you're actually seeing as part of this creation. So the first thing that I'm going to do is I'm going to start by working in the top view, and I'm going to draw flat in the top view to begin with. And let me zoom in here. There we go. And I'm going to draw the object that's shown on your handout, which is also, of course, available on the course website if we were to download it. Sorry, wrong exercise. I thought I had it pulled up. That was for this morning. And notice that 205 is in the wrong order. I have no idea why they're showing up in the wrong order. They're not supposed to, and I haven't been able to figure out what the problem was. But in 205, this is the image that we're working with. And we're going to start right at the bottom corner right there as we start to draw. So I'm going to use the polyline tool, which we've used before, and I'm going to start at point 0, 0. And I'm going to draw a line that's the length of one side of this bridge. So if I look at the dimensions, it's 36 inches. So I'll type 36 and then enter. Remember, our default units are in inches, so if I type 36, it's going to be 36 inches. After I've drawn that straight line, I'm going to move over in this direction by 4 inches, like that. Now, here is a perfect opportunity of where, as you're just drawing naturally in Rhino, using absolute coordinates is relevant. So far I've just done distance and direction. In this particular case, I need to go over 2 inches in the negative direction and down 36 inches to create that sloping side. So I'm going to use the @ sign, followed by -2, which goes -2 in the x direction, followed by a comma, and then -36, which gets me in the y direction. And there it is as my sloping diagonal line. Using that absolute coordinate here, or excuse me, using that relative coordinate is a really easy way of creating that line. If I had to create it in a different way, I'd have to draw a little guideline and figure out where that point was. And so this really makes life easy to create that. So then I'm going to go down by 6 inches. And now I need to go over. So this is the same thing. I'm going to use a relative coordinate. So I'll use the @ sign. And this time it would be 30 inches, comma, -6 inches. And that creates that sloping bottom for me. So again, I'll use relative coordinates. It would be @ this time it is 30 inches again, comma, +6 inches. Enter. And that creates the other half. We'll go straight up by 6 inches. And then we'll do the @ sign. This time it would be -2, comma, 36. And I get that slope. We're going to go over 4. Down 36, and I'm going to type C for close, which creates the closed polygon that represents, or polyline that represents my object, which is essentially what you're seeing on the handout as well. So there are, of course, other ways of working through this, and I'll show you as we go along, giving people a chance to catch up a little bit as I go through it. But I could draw just part of the object too. So I could start, say, start at 24. I'll go up 36, over 4. Same thing at -2, comma, -36. down 6 at 30, comma, negative 6. And that gives me half the object. I could then take this and mirror it to draw the second half. So there's nothing wrong with doing that as a method. The point is that there are ways of kind of working this up. I will also show you a strategy for how, if I were actually building it, how I would go about building it using these kinds of techniques to save some steps. For what we're doing today, though, it's a good idea to go through and actually have to create all of the stuff because it's good practice. That's the point, is learning these skills. So I'm going to switch from the top view, and I'm going to move into the perspective view. So I'll double-click on top, and then I'll double-click on perspective. It'll have me zoom in on the perspective view. We'll orbit around just a little bit. And I want to rotate this object up into the flat plane, or into the z-axis here. So I'm going to use Rotate 3D. It's under Transform, and then Rotate 3D. I could also type in Rotate 3D. And I'm going to take this. My axis of rotation is going to be around this line right there. So I'll go from there to there as my axis of rotation. And then I want this to jump up. Now, if I didn't have ortho turned on, it would be much harder to determine where 90 degrees is. And it would be easy to get it kind of skewed on a funny angle, which of course we don't want. So if I don't have ortho turned on and I go through and I do my rotate 3D like this, I can either turn on ortho or I can hold down shift. If I hold down shift, it'll jump to that 90 degrees. So I have a tendency while I'm working in Rhino to just leave ortho turned on unless I need something that's not at 90 degrees. But most of what I'm doing is at 90, so I'll leave it turned on. So we'll have it jump right up there to be in the vertical position. And we can confirm it. Sometimes it's useful also to double check in the side views. Yep, it is perfectly vertical. It looks good in those views. I'm happy. So we'll come back to this particular object. And now I want to offset this set of curves back over here. So if I type in offset, and I type in a distance of 4 feet, I think that's what I say to create, right? 4 feet, yep. It's going to be going back in that direction. Notice up here in my options that there's something that says in C-plane equals yes. We want to make sure that that is set to yes. Sometimes it's set to no. In some weird way, it might be set to no. If it's set to no, it's going to make a larger object around my object. So we'll go back here. We're going to set in C-plane yes, which means it's going to be going back in this direction or forward in that direction. I want it to be going backward. So we'll go ahead and click on this side of the object, and I get my second object here. The other thing that is a useful thing to point out is that if I'm doing the offset, and I do the offset in, say, the front view here, it's going to assume that I want the offset to make my object in this plane. But if I switch to the perspective, suddenly the offset's going to go backward. So it changes depending on which view I'm in as well. We're working in the perspective view, so chances are your offset is going to work as long as the in C-plane option is set to yes. I will explain at much greater length later on in the semester what C-planes are and why they're useful. But for right now, we don't need to worry about C-planes. It's a little bit too complicated for where you are. So from here, I say in step 3 to go ahead and explode these two objects. And I'm going to explode them for the practice of having to loft all the individual pieces together. In reality, I don't have to do it this way. So let me do explode first. And then I'll select two opposing curves. So there and there, for example, and I'll type loft. Or select surface and then loft. And I'll work my way around the object. So I could go to these two, loft. There, loft. You guys get the idea. Now, I can do a loft of all of them at once. If I didn't explode them so that they're whole pieces, I can select this and I can select that, and I can go up to surface and loft or type loft. Now when this happens, it's important to make sure that we're starting at the same point on both curves and that our arrows are facing the same direction. So right now, they're starting at the same point. They're facing the same direction. If I hit enter, it will then wrap around my object and do all the surfaces at once. There's nothing wrong with that as a strategy, but it's important to get used to the lofting operation to begin with. So doing them as separate isn't necessarily bad. If I did it like this and my points were not at the same point, say something like that, when I go to make the loft, it's going to match up the sides a little bit wonky, and I'm going to get this twisting shape, which is not what I want. Same thing would happen if I went to do the loft and my, come on, there we go, and my curves were going in the opposite direction, then I get this, where all of them intersect. So how those, and when you're doing a loft that contains multiple curves, making sure that the loft actually happens in the same direction across the same plane makes all the difference. So I like to at least point that out. You can, of course, explode and do separate lofts for each one. There's nothing wrong with that. You're going to get to the same spot. So there are my individual pieces there. OK, so now I need to fill in the sides of these, because obviously it's hollow, and I'm working toward creating a solid object. So it's pretty easy to start. I can use my surface from 3 or 4 corner points, and I could fill in, say, 1, 2, 3, and 4, and that then fills in that piece there. Notice that I'm limited to 4 corner points, though. And in this case, it actually is better to do this as separate little operations rather than doing one big piece. I could create a curve or use this curve here and do a patch, which would fill the whole thing, maybe. Looks like it's not going to like me. But when we go to do the chamfers, when we bevel the corners, it's not going to work out quite so well. So let me see if I can get out of this, or whether I have to wait. There we go. So I got out of it. So doing it this way is actually not a bad strategy. So what I'd like you to do next is continue with the surface from 3 or 4 corner points, and we're going to do a little triangle in the corner. 1, 2, and 3, and I'll hit enter. So it's a little triangle like that. Trust me on this, it will make your life a little bit better if you do it that way, as opposed to doing it from here to the middle, down, and back over. I'm going to continue. 1, 2, do the middle here, 3 and 4. And we'll continue 1, 2, 3, and 4. Corner. And now I've filled in that particular side. The back side, I can do the same way to keep filling it in, or I could select all of the surfaces that are on this side, like that, and I could then mirror across the middle of my object and fill in the side that way. Doesn't matter which way you do it. So now that I have this as a semi-solid object, and I use that loosely because obviously inside this object is still hollow. I could zoom in and see inside the object. Now it's time to start kind of finessing what this is going to look like. And this is going to take a little bit more time to work through. Building the basic shape isn't so hard. It's the details that start to matter. What I want to do is I'm envisioning this as a piece of concrete. And generally, when you have 2 seams of concrete, there's some kind of a transition. You don't have continuous concrete to continuous concrete. There's a joint, and that joint is where cracking and stuff would happen. So it's called a control joint. I'm going to create that, or at least half of that, along these edges. And I'm going to use the chamfer command, which is chamfer and then SRF, because I'm doing it to surfaces, not curves. It's right there. And I'm going to set my distances not at 1, but at a 1/2 inch each. You could do it less, but a 1/2 inch seems to work nicely. So I'll type 0.5 and 0.5 for my second distance. And what this essentially does is it allows me to pick this side and create a convenient little bevel that goes along that edge. You guys see that? So I'll continue to work my way from here to there and from there to there. So I've essentially created a little bevel that goes all the way around this particular piece. Now, if we look carefully, see how this, when it happened, it left a piece of the surface long. It didn't actually join them quite right. So there's always some cleanup that needs to happen. But I'm going to take this a step further and make it a little bit more complicated. And I'm going to repeat the chamfer again for this surface to that surface. So now not only do I have a chamfer here and there and across the top, but I've got a really nasty kind of center that's happening right in there. So what I'll do to solve this problem is I'll use my polyline tool, and I'm going to drag and draw a triangle that goes across all of those points. So that is the triangle that I'm trying to create. You guys see how that works? It's kind of on a slight angle. I can then use this triangle to trim off all the excess surfaces that I don't need. So I'll type trim, and I'll work through and I'll trim off these extra pieces that I don't need. And part of the reason that this is particularly useful is you have to start to see where and what pieces to get rid of. Notice though, as I'm orbiting, that it's really hard to keep this. Let's say I'm zoomed in here and I go to move, it jumps around. You guys see how that happens? Rhino sometimes has trouble when you have a large object and then you suddenly are working on a small detail and keeping it as the center of your attention, so to speak. So I'm going to use a little trick here to do that. I can come back to the trim. I'm going to use zoom, which we're used to, but I'm going to zoom selected. Notice I have that triangle selected. When I choose S for selected, it recenters my view around that one object. So now all my orbiting goes around that object. That object stays in the center, and everything else, no matter how big it is, doesn't matter. So this can save your life quite a bit when you're working on small scale stuff versus a really big drawing. If I want to go backwards and see everything, I can type Z for zoom and then E for extents. That will show me everything, and I'm back to revolving around everything. So zoom S for selected, I'm back in tight, and I can work around this particular object. Let me continue with my trim, and let's get rid of that piece there. So now I have a nice little corner, but I do need to fill that in with a surface. So I'll come back to my surface from 3 or 4 corner points. 1, 2, and 3. And I've now filled that corner in. Let's do it again over here. So chamfer surface. I need to do this edge and this edge. Go. I'll draw my triangle. Point to point to point and back. I'll select it. Zoom S for selected. And then I need to trim those extra pieces off. So we'll go to trim. We'll get rid of that. That. Looks pretty good. Enter. And then I'll go ahead and fill this in with a piece as well. So a large part of this is learning, kind of zooming and interacting with your object so that you can get these nice clean corners. So you'll continue and you'll do the other side here, and you'll continue and you'll do the side here, and you'll do that piece there. Don't worry about the ground here to the face, because we don't need that joint. We're going to skip that one for right now. I do, however, want you to continue down this side. So let's keep working at it. We're going to chamfer the surface again, there to there. Now that does a pretty nice transition. Don't really have to do any cleanup. Then we get down here. This one's messy. Okay, so let me chamfer the surface again, there to there. And we've got a little bit of a problem. See how that doesn't line up with this? If we were rendering this and we had a bunch of these stacked together, does that little point matter, that little gap? Not in the least. So we could just stack them all together and forget that. And it really doesn't make any difference. However, if we wanted to 3D print this object, that little gap would cause us not to be able to 3D print. Okay, and there's ways of finding where these gaps are, and I'm going to show you that when we get to the 3D printing. That's where being really clean matters. So now we have to fix that problem as well. So let me zoom in here, and we're going to work on fixing that problem. So as I look at this, essentially what I need, and there's two different ways of working through this, I need a surface that goes along there and then would come from this point down to there. So if I drew a line from that point all the way up to that point right there, I'll hit enter to finish that. I could use that line as a trim. So let me go ahead and trim, and I could get rid of that piece of surface. So now this surface here meets up at that corner quite nicely. This surface doesn't help me, so let's get rid of it. I'll just press delete. But we already know that I could get a curve along that edge and a curve along this edge, and I could loft the two together. And it would twist a little bit, but it would be a nice, clean surface. So I have one curve here, but I don't have a curve down along that edge just yet. So I'm going to use something called a duplicate edge, and it's available under Curve, Curve from Objects, Duplicate Edge, or you could type in Dupe Edge. And what duplicate edge does is it's a way of deriving geometry from an existing object. So I need a curve that's right there along that edge. Give me a curve that's right there along that edge. When I press enter, it'll give me a curve. So in this context, could I have drawn a straight line? Sure. But if you imagine a more complicated surface, it would be nice to just give me the edge of this surface. So now I have that, and I have this piece here. And I could simply just loft the two together and say OK, and that would give me that nice little loft. Technically, this curves ever so slightly, but it fills in that corner and gives us a nice sharp point at that corner. Now, I could take it a little bit further, and we could chamfer this to this, which would give us yet another complicated corner. And I could do from there to there and to there and back to there. I'm going to select it, zoom S for selected, do a little bit of trimming. There it is. Surface from 3 or 4 corner points. And I could fill that piece in as well. So certainly I recognize that this is tedious. But at the same time, this is about learning your skills and working through these kinds of details. And if you do intend to 3D print an object, you have to deal with these problems. Okay? There's a little tiny hole here as well, so let me fill that one in. There we go. I'll fill that one in. And I'll come over here, and I'll do the same thing for this side. This time I'm going to do it slightly differently, just so you can see that there are other ways of doing it. The way that you do it doesn't make any difference. It's just the act of getting it right. Okay? So let me go ahead and chamfer the surfaces again. And I'm going to do this to this and this to this. And I have the same problem right there with that little gap. This time I'm going to modify these two surfaces instead of changing them. So the first thing that I'll do is I'll take this first surface, and I'm going to come over here, and there's something called Edit Points. And I'm going to, oops, sorry, it's this one. It's Points On. I want points on for this object, and it'll give me a little point that controls the object, that surface point. Unfortunately, that surface point isn't, let me zoom selected for a second, so we're reorienting. It's not, it's in plane with the object, but it's not, see how there's a lot more to the object? If I were to just move that point to that point, I'd end up with a gap, and that doesn't work. So I have to do something else first, and that's called untrim. So we have trim, where we get rid of pieces, and untrim gives us pieces back. So when I did the chamfer, it trimmed for me as part of the chamfer. I'm going to do untrim, and I told you this is the more advanced way of doing it. There's nothing wrong with the other way that I did it. It says select edge to untrim. I want that edge back right there. Oops, sorry. I picked the wrong edge. There we go. And I want that edge back. So now it's as if those chamfers didn't really happen. I can take this, oops, I can take this object and turn my points on. I can type points on. And I'm going to move that point to that corner. And I'm also going to take this object and turn my points on. And I'm going to move that point, if I can type, from right there to right there. And when I do that, that corner now matches up nicely. I have a little bit of a problem down here that I have to solve. I go ahead and move this point. Oops. So right there. And that point to right there. So essentially, in this scenario, I've adjusted the points of my object rather than creating a new surface altogether. I do look like I have a little bit of a problem here in the middle where those two don't quite match up. That's because of the way that they're twisting. And so in that context, I might have to make another adjustment or rebuild that surface to solve that gap. I'm not sure why this one isn't a straight line. It should have been. So I think it's probably better to do the first method. Let me duplicate the edge there, and then I'll loft them to create that. It's probably a better strategy anyway. But I like to introduce the concept of points and edit points and that you can actually move points around. So then I'll continue the rest of the way up here, chamfer surface, and I'll work my way up the rest of the object. Okay? Now, I told you earlier that if I were modeling this, I'd use some tricks. And if I were using tricks, essentially what I'd do is I'd draw this half of a shape. I'd rotate 3D on that half of a shape. I'd flip it up. I'd offset this not by 48, but by 24. I'd loft these two together. I'd fill in just one side. Like that. I do my chamfers. I'd make my corrections. Like that. I'd fill this in. Like that. Once I had all of that done, I'm only doing it on one side. I'd take this object and I'd mirror it first that way. I'd take these two and mirror it this way. So in terms of efficiency, I'm only doing that detail work one time, and I'm, by mirror, multiplying it out 4 times. So this is certainly the efficient way of doing it. But for your purposes and learning the process, doing it over and over again is not a bad thing. But I at least like to point out how, if you're smart about modeling objects, you can end up using one side, if it has repetition, using the mirror. So once I'm done, it is time to set this up. I'm asking you to do a render as part of this. You just did rendering last class, so we're going to repeat what we did last class as well. First thing that I need is an infinite plane underneath my object. So remember, up here in the V-Ray toolbars, we're going to select the Add V-Ray Infinite Plane. It would be nice if it was on its own layer. So let me move to layer 2, and I'll call this Infinite Plane. There we go. I'm going to click this button for Add V-Ray Infinite Plane. There it is. I'm going to select, or excuse me, I don't have to select it, but I am going to switch back to default, and then I'm going to lock the infinite plane so that I can't accidentally move it. OK, so I have the infinite plane. I need a light. So let's use layer 3 for this. This is a directional light. I'm going to use a little cheater object, my box, to set up my light. There's my box. The directional light is the hidden button at the end of the V-Ray toolbar. End of directional light vector is right there at that corner. Start is right there at that corner. So I have light coming down. We'll get rid of the box. I'll move back to my default layer, and I could choose to lock the light as well. Now I have the infinite plane and the directional light set up. It's time to assign some materials. Notice, however, that the way I built this, the bottom part of my little bridge is underneath the infinite plane. I need to make a correction there. So I'll select my object. I'm going to come back into the side view. Front, right side doesn't make any difference. And I'm going to move so that my object is up a little bit. And you can see that it reappears over here in the perspective view. Let me select this object, and we're going to assign a material to it. So I'll go to my V-Ray material library. In this case, I want to load in some material, so I'll click on Load Material. I'm going to go to my flash drive or my OneDrive. I'm going to go into Resources, V-Ray, V-Ray Materials. I want it to be concrete, and I'll pick a basic concrete. You can pick any of the concretes if you want. I'll go ahead and click on Open, and that loads in the basic concrete. Make sure I pick the right one. Yep. I'll right-click on the material and say Apply Material to Selection. And I now should have concrete applied to this. I can confirm this by clicking on the rendered view. And we can see, yep, it does have concrete on it. So that's good. That's what I was after. So at this point, I'll set up a little view of my object. And then we'll go ahead and render it. Yes. Well, and rendering is it's details in terms of the more planes you have, obviously, but it's also the complexity of the material itself. So if we have transparency or we have reflections or anything like that, that also adds to it because it has to calculate more bounces of light. So there are obviously some issues that are part of this material. It didn't apply quite correctly. We're going to cover texture mapping as we go forward. So this is satisfactory for what we're trying to do for today. I'll click the Save button right here in my V-Ray, and then I can post that as my image for today. Do make sure that you save this Rhino file because we'll need it, I think next class. We need this file again. So you have to make sure you save it, and otherwise you'll have to rebuild it again. Okay, so what I want you to do is concentrate on all these little steps. Really work on understanding how to clean up your drawing, how to make those chamfered surfaces, how to solve the little problems that occur along the way. If you run into trouble, let me know, and I'll help you through those little pieces, but I think you should be pretty good. We will, next class, we're going to do some more complicated building. Same kind of thing. It's going to go together. We're going to make more like tubes and rods and stuff like that. So we're building skills, essentially, with what we're doing. Are there any questions before I turn you loose? No? All right.